Hello, Maurieo. In this video I'm going to be looking at calculating the classical half angle that results from parallel sided roads. When I first started surveying way back in the 60s, this is one of the first tasks that I was given. One of the first things I had to learn was calculating half angles. So here we are, we have our problem that we're going to look at. We've got a new 20 metre wide parallel sided road, and it's been designed between Fish Pond Close and Heidi Lane. We have to calculate all the boundary bearings and distances, and the bearings and distances for the what we refer to as the half angles. That's BI, CH and DG. Now before we crack into the classic half angle, we've got to have a look at what's happening here at AJ. Now I've drawn in beforehand in these little magenta lines, apart from the ones that are half angles, I've drawn in the right angles. So they're right angles at the width 20 metres, so we can see where the right angles are. So first one we're going to look at is AJ, and then we draw in the right angle, and of course we can, because we've got the bearing 52, 46, 30, we can just add 90 to that to give us 142, 46, 30. We can subtract that from the 153, 26, 30 that we have there to give us this little angle here, 10 degrees 40. And we know of course that the right angles are all 20 metres because we've got a 20 metre wide parallel sided road. So then we get this little right angle triangle here, and in the right angle triangle there we can calculate x, and x is just equal to 20 over cos 10 degrees 40, which is 20.35 in this case, and we can calculate the little y here, which is y equals 20 tan 10 degrees 40, and that's 3.767. So that's got that out of the way. Now we can start to look at the classic, what I call the classic half angle, which is up here, B to I. Now the first thing we do is we just get our bearings going in the right way so that we can subtract them to work out this angle here, the what we call the actual half angle, or the full angle actually, and then we cut that in half and then add that half to get the half angle bearing. So I'll just start you off with this classical one. So there we go, 232, 46, 30 going out this way, and 125, 1150 going this way. We can take those away and we get 107, 3440, taking them away. We divide that by 2 to get the half angle, 53, 47, 20. We then add that to this one here, to this bearing here. Okay, 125, 1150 plus that is 178, 59, 10. Now that is the half angle bearing, 178, 59, 10, which I can write in up here, 179, 58, 10, and then we add these bottom two together as a check, because we should end up with the one at the top that we started with. There we go, 30, 46, 232. Check, all done, nice, done and dusted. Okay, so now we start with, we get our little triangles in here, and we want to calculate BI, and BI equals our width, which is 20, over sine 53, 47, 20, our half angle, 24.79. So there you are, we can write in the bearing, 178, 59, 10, 24.79 for the half angle. And then we want to calculate this little piece in here, this little bit here, which I have called x, and x is equal to 20 over tan 53, 47, 20, the half angle, and that's equal to 14.644. Now, armed with this information, we're able to work out the distance JI, because JI equals 53.26 plus this little piece in here at J minus the little bit that we've just calculated there, the 14.644. So it's 53.26 plus our 3.767 minus our 14,644, and that gives us 42.383, which I have now written in here, J to I, 42.38 I've put, because that's our final one, so we can round that. So then we move on to the next half angle, which is C to H, and 246, 3110, 125, 1150. Take them away, halve them, add the half to this one here to give us the half angle bearing, which I can then write on there, add them together to check that we get back to the top one again. I can't think how many times I've done this down little roads and things, but it's an oldie buddy goodie, and it stays true. So now we can calculate CH, which again is 20 over sine of the half angle, 60 degrees, 39.40, and then we calculate the little piece in here, which I've euphemistically called X. So X is 20 over tan 60, the half angle, 11.241. So now we can calculate IH, and IH is 74.59, which is CB, minus the little piece here, 14,644, plus the little bit there, 11,241, to give us 71.187. And I've written it in here, I forgot to round it, 71.19 would be the go there. And let's move on. It's pretty much more of the same, but so here we go. We look at DG again, another half angle, typical half angle calc there, with the half angle and the half angle bearing. We calculate out our 193, 53, 55, we calculate out our 25.17, and when we calculate in here our little x bit, or the secant distance, I think some might call it, I'm not sure, the cosecant or the there was a name for it, it's escaping me at the moment, 15.278, so then that enables us to work out HG, which of course is going to be CD, plus this little bit here, which was from the previous page there, 11,241, and minus this little bit that we've calculated here, 15.278, gives us 59.53. And then again we're back to the other end of the road, we just come straight across on our right angle, very steep, very difficult to see, but there is one in there as I've drawn here. And remember that it's just at right angles to the bearing. We take them away, 4 degrees 53.30, just add them on, make sure we get back. Let's do some little checks, and then we get FE is 20 over cos 4 degrees 53.30, slightly different perhaps triangle than the other ones, but we're using the cosine at that one. That gives us 20.07, which I've written on the diagram, and then we also calculate the little x as 1.712. So we can now calculate G to F, I think it is, but F seems to have disappeared on us, but never mind, F in here. So it'll be ED minus this little piece here, and as it happens, minus this little bit at the top, so minus 1.712 and minus 15.278 gives us 40.90. Now this type of situation here is very easy to draw up in CAD, and in fact that's what I did in this situation myself, is to draw it up using a CAD package just as to check, because it's important that I get things right. So as I calculated each one, I checked it off on my CAD. So that's very helpful, particularly if you're perhaps doing a question yourself. You can draw it up and have some confidence in the answers you've got. So there it is, the classic half angle calculation.